morning, everyone. Thanks for watching this video. I am Raja Shanmugam, responsible for IoT and Digital Engineering Business Unit and Global Business Development within TCS. And I'm happy to share my perspectives on future of engineering. And I believe the future of engineering is around bringing life to things. What it means is it is not about just designing a product to do its particular defined way of doing things. We feel that the future is more like bringing life to the things itself, those products itself. Products should be able to act for its defined way, but it also should be able to react to the change in surroundings, and also it should be able to take a cognitive functions so that it should be able to learn and adopt on the field. So that is what we call it as a self-aware systems and autonomous journey of the products of the future. And there is no better time than today, because today with the advent of IoT, digital twins and artificial intelligence and sensors, fusion technologies and image and video analytics and all the plethora of technologies have come together and in a proven way to adopt at scale for the industries. So it is going to be more exciting time for all of us who are engineers and who are defining the future in this way. And let me give you 3 examples and how it is changing. Right? And we all have heard about autonomous cars and level 2, level 3, level 4 functions. We believe that autonomous cars is going to really reduce the accidents on the road and bring much more comfort for the passengers and much more availability of time for the passengers. And so let me give you an example, because we have our own cars, our own autonomous cars, which is developed by TCS and running in our Chennai facility as well as in Pune facilities. And the beauty is today I can go and call for the car and stand in a place and call the car will automatically come and pick me up. And similarly, if I want to get dropped in a particular place and ask it to go and park itself, it will automatically go and park in the parking space on its own. It's not only that, actually, if I have more than one car, I have in Pune facilities multiple cars. So if I have the first car moving in without a driver in an autonomous way, and the second car, it can follow as a fleet. And the moment first car brakes, it automatically second also will brake, and it will follow the route as defined by the first car also. So it is more like the human-like functions. You are able to bring it into the autonomous car. And today it is within the campus, and I am sure the future is going to be, we will see autonomous cars even in Indian roads. So it is not far away. And not only on the cars, and if you look at it on the logistics, and we are all enjoying the door deliveries from all the e-commerce players, right? And if you look at it, the background or the back end of this logistic chain is their sorting centers or their warehouses, which is the biggest constraint for them to deliver it around the clock, because all the incoming parcels needs to be sorted out and then distributed to the right location. So that is more like the heart of the operations for the logistics. So today we are working with a customer in the Nordics, Europe, to improve its logistic customers to increase the throughput of the sorting centers, leveraging autonomous mobile robots. It is called Paul Picker, which is again developed by TCS with some of our partners, where we have brought it up. And now this autonomous mobile robot called AMR can run 24 hours, and it will be able to sort all the parcels on its own or pick and drop in the warehouse sorting center. So that is how the availability and the throughput of those sorting centers or the warehouses can improve much more. And not only that, it is also relevant for plant. And we are seeing plants are asking for, how can I improve my flexibility and drive autonomous plants? One example I want to share here is, it's a power plant. And actually, if you look at thermal power plants, have been designed more than 20 years ago. And for them to today's scenario is, and when it was designed for full capacity. And that thermal power plants will produce so that on a continuous manner and for its full capacity, so that the efficiencies has been maintained accordingly. But today the need is it is used as complementing the renewable power generation. So when the renewable power generation is high, it will operate at a low capacity. When the renewable power generation on wind and solar is low because of probably cloudy weather, etc., then it will operate at a higher capacity. So such a flexible capacity, when it operates, then your efficiency goes for a task. And so that is where it is physically and humanly impossible to manage all the 200 parameters for every varying degrees of load conditions. So it is important to bring in artificial intelligence into that, so that for the varying demand, the artificial intelligence modules will be able to define the criteria for the settings which will give the optimum efficiency for the power generation, and it will also be able to implement that settings into the control systems. So this entire digital twin is driving the power plant. Not one, this is just one use case. Like that, there are 50 use cases together. You can drive entire power plant in an autonomous way. So, which will help in improving the efficiency, which will help in reducing the emissions to the market. So, the future, I feel the autonomous journey, it is not only a fancy thing, and it is going to really define the future to be much more efficient and much more safer and much less emissions to the world. So, we can really go towards even net zero across the companies. So, there is no better time than this for defining this autonomous future, and we all our engineers are going to drive this further. Thank you very much.